Alright, for section 11.2, take a look at 3 problems today for your homework help. First one's going to ask you to find a unit vector in the same direction of u, which here's u, and then for letter B in the opposite direction of u. Second one is going to ask you to determine whether the points 0, 4, 4, negative 1, 5, 6, negative 2, 6, 7 are collinear by using vectors. And the last one is a story problem where we have a weight of 735 pounds being supported by 3 ropes. The weight's located at this particular point. The ropes are tied off at these 3 points, and they want you to find the force or tension on each rope. Alright, so starting out with the first one, find a unit vector in the same direction of u. So for it to be the same direction, I want to keep these coordinates basically the same. I'm just going to find this one's unit vector. If I find the unit vector for this, it's still going to be going the same direction. So it's basically just asking to find the unit vector. So that would mean I need to find the length of that, or the magnitude of it. So if I find the magnitude of u, that is going to equal the square root of negative 3 squared plus 5 squared plus 10 squared, which I know is going to give me 9 plus 25 plus 100, or that's going to give you the square root of 134. So, to be going in the same direction, I just want to keep the signs the same, and the unit vector would be negative 3 over the square root of 134, or if I rationalize, it would be negative 3 square roots of 134 over 134, comma, 5 over the square root of 134, and again, if I rationalize, it'd be 5 square roots of 134 over 134, and then it's going to be 10 square roots of 134 over 134, and I know 10 over 134 can be simplified, so before I go ahead and write that out, I'll go ahead and simplify it. 10 over 134 as a fraction simplified is 5/67, so it would be 5 square roots of 134 over 67. There is the answer to part A. Basically just saying find the unit vector for this. Now if I want the unit vector to be going in the opposite direction, just need to switch all the signs is all. So the unit vector, without having to show any work for it, would be positive 3 square roots of 134 over 134, comma negative 5 square roots of 134 over 134, and negative 5 square roots of 134 over 67. So fairly quick and easy problem as long as you understand what it's asking you for. Basically just finding the unit vector for that. Alright, next one says use vectors to determine if these 3 points are collinear. So what I need to do is I need to come up with a couple vectors. Now if I call this point A, point B, point C, it doesn't matter, let's say that that's vector AB, it doesn't matter which direction I go. The slope of it might be different, but in terms of the direction, it's not going to make a difference. The slope's going to end up being the same. Like if it's going that direction or that direction, it's still going to have a negative slope. So it doesn't matter if I do A minus B or B minus A. That's not going to make a difference. And then there's 3 possible vectors I could have. I could have the vector AB, I could have the vector AC, I could have the vector BC. I only need to use 2 of these. So these are the 3 points. Let's say these points were collinear. There's vector AB, for example. There's vector AC. Here's vector BC. I really only need to use 2 of them to show that they're collinear or not. So I don't need to do all 3 of them, but I will just to show it. Alright, so for AB, from A to B, it doesn't matter which way I subtract, so I'm going to take 0 minus negative 1, so 1, 4 minus 5, so negative 1, and 4 minus 6, so negative 2. There's the vector from A to B. From A to C, I'm going to say it's 0 minus negative 2, so positive 2, 4 minus 6, so negative 2, and 4 minus 7, so negative 3. And realistically, that's all I need. So I'm going to show it, and then I'll do BC and show that it's still going to work the same. Now remember, in order for them to be parallel, they need to be going obviously the same direction to show that they need to be multiples of each other. So can I get this one to look like that one? Well, I can factor out a 2 here, and that would give me 1, negative 3 halves. And when you look at these 2 vectors, those 2 are good, but that z term is not. So these I know are not collinear. So when it says, are they collinear, you can just say, no, they're not. Now, if I did go ahead and do B, C, again, the order doesn't matter which way I subtract them. Let's say I do -1 minus a -2, so 1, 5 minus 6, so -1, 6 minus 7, so -1. You can easily look at these and see that they are not. I can get those two to be the same, but again, I can't get that third one to be the same. All right. So the one that's got a lot more work and a little bit more difficult is the last one. And it says the weight of 735 pounds is supported by 3 ropes. The weight is located at point A, which is 0, 2, -4. The ropes are tied at the points B, which is 600, C, which is 080, and D, which is -101. I want you to find the force or tension on the ropes. Now in class we wrote down some steps that you should probably do for this. And what you're going to want to do is you're going to want to find the unit vector for each rope to the weight. So I need to find a vector from A to B, from A to C, and from A to D. So I'm going to do that. I'm going to find the vector from A to B. And I'm going to go from A to B, so I'm going to take B minus A. So it's 6 minus 0, or 6. It is 0 minus 2, so -2, and then 0 minus a -4, so +4. And then I'm going to do the same thing for A to C. Going to find its vector, and that's going to be 0 minus 0, so 0, 8 minus 2, so 6, and 0 minus -4, or 4. And then the vector from A to D is going to be -1 minus 0, so -1, 0 minus 2, and 1 minus a -4. So those are the vectors. So that was step 1 that we had written down. Is it said to find a vector, or actually says to find a unit vector. So to find the unit vector, I now need to find the magnitude. So if I do a squared, b squared, c squared, it looks like I have 36 plus 4 plus 16, or that's going to give me the square root of 56. So the unit vector is going to actually be all of those numbers over the square root of 56. And you can go ahead and find that right away instead of just doing that if you wanted to. So the unit vector for AC, or the magnitude of AC, is going to be squared, squared, squared. Obviously I don't have to worry about that one. It's going to be 36 and 16, which is going to give you a square root of 52, so it's still going to be 0, 6 over the square root of 52, and 4 over the square root of 52. And then the magnitude of AD is going to be 5 squared plus 2 squared plus 1 squared, so 25 plus 4 plus 1, or that's going to give me 30. So the magnitude is 30. Unit vector would be -1 over square root of 30. I would have -2 over square root of 30, and 5 over square root of 30. Alright, and so I have this written down. The magnitude of that vector is actually the square root of 30. The magnitude of that vector is actually square root of 52, and so on. Alright, so now what I want to do is I want to use, or I want to write what we call a force vector. So that's basically what I have right here. This is the force vector. This is technically the magnitude, what I have written here. The force vector is the magnitude times the actual direction. So I'm going to do this. I'm going to say that, let's put a line here. I'm going to say that vector u is going to be represented by looking at the magnitude of vector u times looking at, in the numerator, the direction of the vector divided by the magnitude of the vector AB. I'm going to do this for each one of them. Now, the direction is this thing. The magnitude is the square root of 56. This entire thing is actually that vector. So what this is going to equal, my vector u is going to equal the magnitude of u times the vector 6 over square root of 56, comma -2 over square root of 56, comma 4 over square root of 56. So however you want to think of it to help you remember this, basically what you need to do is you need to find the vector, you need to divide it by the magnitude, and then you're going to multiply by the magnitude of u, which this is representing the force or the tension on the rope, so that's what I actually have to try to find later on. Alright, vector V, I'm going to do the same thing now. I'm going to do it with AC. This would be the magnitude of the force of V, which is what I'm looking for, times the direction of vector AC divided by its magnitude. In other words, the unit vector. So my vector V is going to be the force of that rope times this unit vector, which is 0, 6 over square root of 52, and 4 over the square root of 52. And then vector Z is again the force of the rope of AD times the direction of AD divided by the magnitude, so the unit vector, which means vector Z is the force of the rope times the vector, negative 1 over the square root of 30. Notice we're not rationalizing. Don't need to for this. This is not a final answer. Usually a final answer, you want to make sure you always rationalize. If it's not the final answer, you can kind of leave it unrationalized. Kind of like we did, or we will do in 10.5. Alright, now I've got my force vectors. Here's force vector U, force vector V, and so on. Now what I'm going to try to do is I'm going to try to set up a system of equations. So one of the things that we had written down was this. We said in order for everything to be in equilibrium, that vector U plus vector V plus vector Z plus vector W has to equal 0. Now you might be asking, what the heck is vector W, because we didn't talk about it. Vector W is referring to the weight of this object. Think of gravity. You're not moving to the right, up. You're not moving to the right, up or down. The only thing it's doing is it's going down. Gravity is pulling this object down. This is vector W, 0, 0, 700, negative 735. So another way to write this would be I could say that U plus V plus Z is equal to negative W. And what I'm going to do is write a system of equations now using these three vectors and that vector and plugging it in here. So what I do is I come up and I use all of what would look like the x terms here and set it equal to the x term here, and this is the variable. So my first equation in my system is going to be 6 square roots of 56, or 6 divided by the square root of 56, times the magnitude of U. Jump down here would be plus 0, or whatever that number is, times the magnitude of V. Jump down here, it's going to be minus 1 over the square root of 30 times the magnitude of Z. And that's going to equal negative 0, or 0. And there's my first equation in my system. Now I'm going to go back, do the same thing, only this time grab all the Z's. And I'm going to say it's negative 2 over the square root of 56 times the magnitude of U, or the force of U, plus, that's a positive, 6 over the square root of 52 times the magnitude of V, minus 2 over the square root of 30 times the magnitude of Z. And that's going to equal negative 0 again, or of course I can just say that's 0. And then my last equation will be the same thing with the Z terms. So it would be 4 over the square root of 56 times the magnitude of the force vector U, plus 4 over the square root of 52 times magnitude of V, or force vector V, plus 5 divided by the square root of 30 times the magnitude of Z. And that's going to equal, remember, negative W, so positive 735. And now if you just replace the U's, the V's, and the Z's with X, Y, and Z, it would be like you're used to seeing. Those numbers are not very nice to deal with, but this is where you are going to use your calculator. So if you ever get a problem like this on the test, you will have a calculator for it. And so what you're going to hopefully remember from chapter 8 is that when you have this, we have A times X. X is considered to be our variable matrix, is equal to B. To solve for X, you would say that X is equal to A inverse times B. So I need to write a coefficient matrix, that's the A, and then there is my B, my answer matrix. So you're going to have to take out your calculator, go to your matrix category, which remember second and then x to the negative 1 here. So second, x to the negative 1. Going to want to go over to edit. So slide over to edit. Pick whichever matrix you want. I'm going to pick matrix A. This is going to be a 3 by 3 matrix. And now I'm actually going to type that in. So I'm going to say 6 divided by the square root of 56. Hit enter. It's not going to give you the exact. It's going to give you a decimal approximation, but it's exact. It's just representing as a decimal. 0, that's a nice one. Make sure you get the signs right. -1 divided by, and you want to make sure that you get all this stuff entered in right. Divided by the square root of 30. You don't want to bump the wrong number. Alright, -2 divided by the square root of 56. Hit enter. Next one is 6 divided by the square root of 52. Hit enter. -2 divided by the square root of 30. Hit enter. Last row, it's going to be 4 divided by the square root of 56. 4 divided by the square root of 52. And 5 divided by the square root of 30. And now I've got all my information for my coefficient matrix entered in. Now I'm going to clear out of here, so second mode, go back into that matrix category. Under edit, make sure you don't pick that same matrix, pick a different one. I'm going to pick B. This is now a 3 by 1 matrix, and this is the answer matrix, which is 0, 0, positive 735. And now I just need to enter that into my calculator. So I go second matrix, this time under names, pick matrix A. I want its inverse times. Go back into the matrix category, under names, pick matrix B, hit enter, and that will be the force on each of those ropes. This one's obviously representing the U, the V, the Z. So you would say that you have a force of 126.93 pounds of tension, and that would be at, that's for AB, U is representing AB, that would be at point B, so it would be at B. We can say that there is 285 let's just say 4 pounds of tension at point C, and there is 557.4 pounds of tension at point D. And there is your answer. So once you get it down to here, if you can get it to this point, you've actually done the hardest part. That would be hard to solve it if you didn't have the calculator, but you'll have the calculator handy. Alright, and when you look back at it, if you look at these ropes, rope AB, look at the length of it, it's the square root of 56. Rope AC, the length of it is the square root of 52. Rope AD is the square root of 30. AB is the biggest rope, AC second, AD third. Notice the tension on them. The longest rope has the smallest amount of tension. The shorter the rope, the more tension you end up with on it. Alright, go through that a couple times if you need to. Have your notes beside you. If you're still having trouble, by all means come in and ask me and I'll try to help you out best I can. But there is your homework help for section 11.2.